Review of complex number fundamentals. We talk imaginary number. What we're doing is we're creating something that does not exist. When we have a square root, or any root with an even number, like this, a 2, a 4, square root of a fourth root, a sixth root, we cannot have a negative as a result. In other words, -1 times -1 equals 1. So even as negatives, in the beginning, we cannot have -1, square root of -1 square root of 1 to be -1. It is not. It is an odd root, like cube root of 3, which is -1. That'd be -1. -1 times -1 times -1. Yeah, I apologize for my limited writing on here. But -1 times -1 is 1. And then 1 times -1 goes back to -1. So if it's an odd root number, like 3, 5, 7, we can have negatives for the result. But if it's even, like 2, 4, 6, that makes all the negatives become positive. But we can use the square root of -1 for two main areas, actually 3. We're looking at atomic structures, and we're looking at atomic decay, and also during regression analysis, which we'll learn towards the end of the semester, to see why even any event starts at point 0. We can see what it preludes prior to this may cause this. We can use the complex number in -1. So basically, let me erase all this mess here I've drawn. And what you see here in the top part, I'll get to it in a second here, is what we call the square root of 1. Rather than write square root of 1, we call it I. I as italicized I. That stands for the -1, square root of -1. It's called for the imaginary unit, I. And I, as I said, equals -1. A couple interesting things here. I squared is the same as the square root of -1 times the square root of -1. And that result is not 1, it's -1. If you understand that, the rest won't get any harder. And it really builds on groups of 4, because what goes on here is I look at the I to the third, well, that's square root of -1 times square root of -1 times square root of -1. We've already determined square root of -1 times square root of -1 is -1 right here. And that would be the square root of -1 times, -1 times square root of -1. And 1 times square root of -1 would just simply be -I. Square root of -1 is I. Let me erase this again so we can keep building from here. And then, if you notice, what gets a little more interesting also is the square root of I to the fourth, which is just the square root of -1 times itself 4 times. Well, square root of -1 times square root of -1 is -1. And then the other square root of -1 times square root of -1 is -1. And -1 times -1 is 1. And then it repeats itself, because I to the fifth is the square root of -1 4 times, which is 1, as you just learned. And then another square root of -1 is left over, or I. So the I is square root of -1, and so is I to the fifth. I to the sixth is the same as that square root of -1 4 times 2 more square root of -1s. And that is -1 if we go to the second one. So it is 1 times -1 times I, so it's -1. Same thing with the 7. That's square root of 1 4 times, which as we know is 1. And then Square root of -1 times square root of -1 is -1, and then another I. So it's basically 1 times -1 times I, or -I, same as the third. And then the fourth is really just square root of -1 4 times, times another square root of -1 4 times. And that's just 1 times 1, which is 1. It repeats in intervals of 4. And we can create, with this, multiple new variations of numbers. And notably, when we look at this here, we will see things such as 3i. 3i is the actual number 3, and that's the real number. And then the I part is the imaginary number. And combined as a unit, this is called a complex number. Complex number. And then we can do things such as, 12i, or I to the square root of 5. And we can do such things as 2 plus 7i. And again, these are called complex numbers when they're used simultaneously. Now, officially defining a complex number is always in the form a plus bi, where a is the real number. And actually, b is part of the real number, but b is touching, in terms of multiplying it, against the imaginary unit. And we can actually say all numbers are complex numbers. I could have 1 plus I, that's a complex number right there. I could have 1 plus 0i, that's a little thicker, I need to change that. 1 plus 0i, well, that's just 1. And realistically, you just call it 1, but that is a complex number when we write it in this form. And let me erase that. Two minus 6i is a complex number. Negative 5.2i. And as I said, negative 5.2i is a complex number if you write it in the form of a 0 for the real number, and then minus 5.2i for the imaginary number. And conversely, as I was talking a moment ago, 4, because that really could be written as 4 plus 0i. The rules of subtracting complex numbers are pretty much the same as when we're looking at adding variables with exponents. It's got to be the same variable and the same level of exponent. X squared plus x cubed is still x squared plus x cubed. But 2x squared plus 2x squared is 4x squared. So if I have, x squared plus x cubed, I can't do anything with that. But if I have 2x squared plus 2x squared, my variables are the same, my exponents are the same, so I can add it all up, and that equals 4x squared. It's the same process as with complex numbers. And we can use the associative property with this. Let's look at this. A plus bi plus c plus, that should be di, not id. Well, that's the same as a plus c in one component, and then b plus d, that's the same level of I. It's not I squared or I cubed or I anything else. It's the I to the 1. So that's a plus d plus I to the b plus c. Let's look at an example here. Really should rephrase it. 4 examples. 3 plus 5i plus 4 plus 7i. Now, this is what I do. I like putting all my real numbers together. I got a 3 and a 4. That's like to make mistakes. And then I put my 5i and my 7i. Well, 3 plus 4 is 7. And 5i plus 7i is 12i. And we're done. 6 plus 3i minus 4 minus 2i was 6 minus 4 right here. And that's going to be 2. And then 3i minus 2i is simply 1i, or just simply I. 8 plus 6i plus 10 plus 7i. 8 plus 10 is 18. 6i plus 7i, to put together right here, is 13i. And then I want to be careful with this one. 2 plus 2i minus 8 plus 5i. And remember, this minus is subtracting not just the 8, but everything within those parentheses. So I really rewrite it as, I could write as 2 plus 2i minus 8 minus 5i, because everything's being subtracted within those parentheses. So 2 plus 8, I'm sorry, 2 minus 8, this is where you have to be careful, would equal minus 6, and then 2i minus 5i is minus 3i. Now we're multiplying complex numbers. We're using the same properties as with algebra, but we have to be careful and remember what we learned a little while ago about I times I is I squared, and that represents -1. We have to keep in mind what are iterations of those multiple exponents for I are. Let's look at a simple one here. I want to multiply 4 times 13 plus 5i. 4 times negative 4 times 13 is negative 52. Negative 4 times 5i is minus 20i. Now, let's look at this one here. Multiply 2i times the expression 3 minus 8i. Well, 2 times 3 is 6i. Or I say 2i times 3 is 6i. But then I got 2i times negative 8i. Well, 2 times negative 8 is minus 16. And I times I is I squared. And this is where we have to be careful. I squared is the same as -1. So it's actually 6i minus 16 times -1, which is plus 16. As with everything else with complex numbers, as I said, we follow basic algebraic rules. And in this case, we're going to use FOIL on this. First, outside, inside, last. I've got two binomials. I'm going to multiply together. 1 plus 4i and 5 plus times 5 plus I. Well, I'll do the first, which is 1 times 5. 1 times 5 is 5. And I'll do the outside. 1 times I, right here, is I. And then the inside, 4i times 5, which I've done right here. 4 times 5 is 20i. And then the last, 4i times I. And 4i times I is 4i squared. And I'm just going to change my I squared to -1 right here, because negative squared is negative I, times squared negative I. So one of those i's, I squared is -1. So my answer is -1. Now I'm going to rewrite here. What I'm going to do is I'm going to write my answers down here. Let's go in order on what my FOIL outcome was. 5 plus I plus 20i minus 4. And like I said, I like putting numbers together, the real numbers together, and then putting complex numbers together. So it's 5 minus 4, which is 1. And then my I plus 20i is 21i. Go through one more here. We'll use another FOIL binomial multiplication. 2 plus 3i times 2 minus 3i. And this is going to be important. We're going to do this in coming days. If you recognize this, I've got the first component of each binomial is the same, and the second component of each binomial is the same. There's a plus and minus. This is a difference of squares. You know, like x minus a and x times x plus a. And remember, when we get any of this, this is always going to be x squared minus a squared, a difference of squares. And that's going to be important in the coming days. That's why I threw this in here. But let's just multiply this up. Because if you remember, the two middle components, my outside and inside, end up canceling each other out. So my first is 2 times 2, 2 times 2, got down here, which is 4. Then my outside is 2 times negative 3, which is negative 6. And my inside is 3i times 2 right here, which is plus 6. And then my last is 3i times negative 3i, and that's going to be negative 9i squared, because 3 times 3 is negative 9. But we also have an I squared. Remember, an I squared is the same as negative 1. So really what we're doing is putting negative 9 times negative 1, which is 9. So this gets interesting here, because now I have my 4 here, my real number, another here, real number. And my two innermost numbers, my negative 6i, or components, my negative 6i plus 6i, cancel each other out. And the actual answer is one real number, 13.